Hi, good morning. Welcome everyone to our session today on antennas, the gatekeepers of the future Satcom experience. I'm Lise Fuselier with Innovaspace, and I'm delighted to welcome Geoffroy Lerosé from Greener Wave and Amelia Liu from Starwin. We have a very short 20-minute session today, so we are going to try to make the most of it. I'm going to ask our panelists to try to keep their responses as short, succinct, sweet, and to the point as they can, so that we can get through the greatest number possible of questions. And without any further ado, let's jump right in. So the title of the session is about antennas being gatekeepers to the future Satcom experience. So gatekeepers, they unlock connectivity, but they can also be a barrier. First question, in your view, what is the most important capability that you expect antennas to enable with regards to customers with their future Satcom experience? And where do you think they still represent the biggest barrier? So in terms of price, for example, swap, performance, etc. And maybe Amelia, would you like to start us off?
Hello everyone, I'm Amelia, CEO and co-founder of Starwin. Okay, as we know, Starwin is the world-leading Satcom ESA terminal and antenna manufacturer, and also we provide signal processing solution. So as for your question concerning about the the antenna as the dog keeper, and also what's the most important the elements, okay, to be and for the antenna, actually we provide the terminal. So the most important capability, I think, should be the smaller size with a better performance. Okay, just like we launched the world first Satcom robotic dog. Okay, you can see outside at our stand. So that is to use very ultra or smaller size, the ESA terminal. Okay, that is a built-in. Okay, so that is the provide the more convenient and also the easy operation for the end users. This is broadened, the current the market, not only focus on the government and enterprise, but also to the consumer markets. For us, beautiful ladies. Okay, it is a really fantastic, the capability to give the anytime, anywhere, any scenario connections. Okay, so that is can just to help the ladies and to be connected and also to install the other some devices like the pepper spray and also some electrical shock to be as a safeguard. Okay. And so for the barriers for the antenna, I think that is the size, weight, and power consumption, and as well as price. Okay. And so, because, so the current world, you see the Starwin, we have the ultra small size, the KA ESA 30, KU ESA 30, already utilized by our domestic, the market for the emergency recovery, for the consumer market, working with China side 26, okay, and also we have the big customer in Saudi, okay, so we just to customize for them the very small antenna system. So that's why we need to consider the low power consumption by utilizing the different the ESA technology, such as compound approach by combining the digital ESA terminal and the analog ESA terminal. Okay, so that is also very important.
Thank you. Geoffroy?
Yeah, so hello everyone, my name is Geoffroy Lerosé, I'm the CEO and the founder of Greener Wave. So we are bringing on the market this year a new technology in terminals for first the KU band with a totally new technology which is based on passive wave control using reconfigurable intelligent surfaces. And to reply to your question, in my opinion, there are a lot of things that are very important for Satcom terminals at the moment. Flexibility is one of the biggest challenge, I believe. So this is why we are bringing to the market LEO-GEO compatible terminals, which can switch from LEO communication to GEO satellite very easily. We are also bringing to the market, in the meantime, the lowest power consumption on Satcom terminals to allow a lot of new use cases. We plan to have a terminal which is 100 watts globally for GEO connection and less than 60 watts for LEO connection. So ease of use, flexibility, and most important, obviously, would be the price. So this is why we have a roadmap which is in 2 steps. First, we will bring this terminal to the market at the end of the year at a price point which is competitive with any existing solution. But we are working already on a version 2 of this product where we integrate some blocks vertically in order to control the price of the BOM and to be able to reach a price point which is not proposed at the moment, and that will unlock the development of LEO and GEO use.
Fantastic, thank you. You both touched upon the multi-orbit products that you're developing. Kind of want to dive a little bit into that. So multi-orbit, multi-frequency, multi-networks, these are all antenna capabilities that we hear a lot of buzz around. How realistic do you think is the combination of these capabilities in a single competitive user terminal, maybe the keyword there being competitive? And what do you think are the trade-offs that are needed to be able to achieve this single Uber terminal?
Okay. The answer is Starwing Satcom robot dog. Okay, so you can go outside and see our robot dog. It is really versatile and multifunctional because it is actually the compound platform that can be integrated, because it's also the open resources for the KU ESA terminal or KE-ESA terminal. Even it can integrate it with the L-band or S-band, the antenna modules. And in order to have the good, the navigation, the positioning, okay, so it can be also to integrated with, the Starwing, the timing system module, and also anti-jamming antenna module. So actually, this is provide the the multi-orbit, and because the ESA terminal for Starwing, we can work under not only the HTS-GEO but also the MEO and the LEO. We have the lot of successful cases in China and in the Middle East and Southeast Asia and South America also. And so that means, okay, that is really a fantastic result not only for the dogs, and we also have some mobility ESA terminal, not only used for the LEO, GEO, MEO, because it's we got the over 10 cell operators qualification for our KU ESA terminal and the KE-ESA terminal. Since this is a scalable and ESA terminal, actually it worked pretty well under the previous Intelsat Flex Move, okay, and also the work with the Hispersat, they are KA, the satellite, and Arbosat, the SAT, Omansat, Meosat, okay, the China Satcom, AppSat, okay, so it's really fantastic performance. All the cell operators love it, and now, and because Chinese LEO cell operators, just like the Shanghai Space Cell and China Satellite Networks, and they prefer the Starwing's ESA terminal more, because our terminal not only work under their LEO, and also we can just combine with their special request customized for their special needs for the, combining the L-band or S-band narrowband with the terminal together for the land mobility, marine mobility, and air mobility. So I think you see, for this industry, because I think it's a little bit silent, okay? So we need to be more flexible. We need to, going forward, to make more changes. And that is a transboundary change, right? And not only just focus on the satellite communication, but also we need to combine with satellite plus navigation, plus remote sensing, plus measurement, and AI technology driven. Thank you.
Okay, Geoffroy?
Yeah, so the question is about the holy grail of Satcom antennas, which is a multi-orbit, multi-band antenna covering all constellation. So what I think about that is that technologically it's feasible. 2 years ago, in fact, at the Paris Air Show, we did a demonstration of a single aperture controlling both a KU and a KA link. It was done 2 years ago. It was really a prototype. And we saw in the news that Kymeta is also working on the multi-band solution. What I think about that is that first, let's bring multi-orbit connectivity to both the KU and the KA band, because there are a lot of needs in the KU at the moment. There are a lot of needs in the KA in the coming years. Obviously, KU-KA will be the holy grail, multi-orbit KU-KA. Technologically, we can do it with a single aperture, with the same reconfigurable intelligent surfaces. We are working on that. Now, what I believe is one of the barriers would be the front end. So how can you control the whole system with a single modem? We need to be fully software defined. We need to have the tools to develop this kind of antennas to be fully agnostic to any constellation, any standard. Hopefully 5G NTN will come by this time, and we are very much looking forward to develop this kind of antenna for the Satcom industry.
Great, thank you so much. Want to maybe transition to the pricing question, because obviously Starlink has very widely redefined pricing expectations for terminals across the Satcom industry. Amazon's also going to begin offering their own low-cost terminals soon. Both benefiting, of course, from very highly integrated production, and they're able to achieve economics of scale. So how do you think you can get to those price points so as to compete, and how are you trying to scale up your production? Maybe Amelia? Okay,
and so for the price point, I think we shall not only focus on the price point, but also for the target market, because this is a big cake. We need to get our parts, right? But I want to firstly talk about the price, how to compete, okay? So because, as we see the Starlink and Amazon Kuiper, okay, they are the LEO cellular operators. So that's why their terminal used is just a half duplex ESA terminal. That means they can use the very, the smaller size and less cheap size, and to support, the antenna, the whole antenna system. And as you see, the Starwing, our ESA terminal, actually we support not only the LEO, but also the MEO and the GEO. So for the multi-orbit, okay, so from this point, and a price, of course, is a comparative higher than them, but we have our own market share, our target market. We have our government and enterprises, the market sectors, and also we have the customized, as per the different customers' demands, okay? For example, we have the Saudi customer. We just designed the special RX-only ESA terminal with the shark fin antenna, with iridium antenna, okay? For that makes the customer can make a phone call and also can receive the TV channels, okay? So this is also can create the big demands, because we follow up the K account and also to fully meet their demands. This is also the consumer markets. That is quantity is about 20,000. So you can see, I think besides the Starlink, we are the number 2 to get the scalable scale production right now. And beside that, and we have the China Satcom 26, right? And they used Starlink's KA-ESA 30 to empower their consumer markets in Chinese domestic market. So this is also the real demands. We need to find a way and to become more competitive. Okay, we have our own market share, and also as the China LEO cell operators is coming. Okay, it will also just create the more opportunities, of course, challenges and chances for us. And we are the least supplier, Starlink the least supplier of the least cell operators. Okay, so that's why, and we can supply the quantities, the ESA terminal, KU and the KA ESA terminal. So in that case, our supply chain goes smoothly, and also we can come down the purchasing price about the chipset, and we can design our specialized, customized sub-array. So that can make us more competitive. Okay.
Thank you.
So with respect to the cost of the terminals, what I think is that we don't have a choice. When we speak to all the customers, all the prospects we have in our contacts, they all face the competition of Starlink, and they will face the competition of Kuiper for sure. So there are some niche markets where price is much less sensitive, but at the end of the day, if we don't bring to all the operators the tools to fight against the mega constellation, we won't make it. And this is without the volume, because no other constellation than Kuiper and Starlink will have the same volume. So we have to find a way to lower the cost of the terminal without the same volume. And that's what we intend to do, because we use a very different technology. We don't use MMICs, which are a bottleneck in terms of cost as compared when it comes to the moment of the terminal. So by using our technology, which is again a much simpler technology that doesn't use integrated circuits, but rather a centralized front end, and some reconfigurable intelligent surface to do the beamforming, we can reach target prices which are competitive with the enterprise and government offers of these mega constellations. And this is what we are going to do. Of course, this is not in the first step. First step, we will be in line with the cost of the terminals provided by other companies, but we are accelerating on a version 2, and by vertically integrating some parts, which is the key to lowering the cost, we think we will bring terminals that reach the market expectation in terms of cost.
Thank you so much. We have only a couple minutes left, but maybe time for one audience question, should there be one. I see a hand raised in the front. Can we get the gentleman a microphone, please?
I'd like to ask Jeffrey, of course, I know all about the Saffron deal, and that your antenna is so uniquely suited for lightweight aero applications. What's the progress of the project with Saffron as far as the development of a commercial aero antenna? How is that going, and when can we expect to see something?
So this is a program that we announced in June and signed officially in June at the Paris Air Show. So we are working on it. We started with both teams from Safran side and from our side. At the moment, what we are doing is we are unrisking the technology, de-risking the technology with all the aero, certification, including vibration, temperature, pressure, and so on. And the timing to get the antenna flying is about 2 years. So the antenna will be flying in mid-2027.
Are they developing it for both commercial and business jets, or just?
We are working for commercial aviation with Safran. Yeah.
Okay, 1 minute left. Any other questions from the audience? No? Okay, perfect. I have a concluding question for both of the panelists. A little true or false exercise, if you'll entertain me. So the question of the panel was about antennas being the gatekeepers of the Satcom experience. So do you feel that the following sentence is true or false? Antennas are still the main bottleneck in Satcom adoption. True or false? And maybe with a very short explanation, because we have 30 seconds left. Amelia?
Okay, and of course, antenna plays a crucial roles in the satellite communication. Okay, so I think the most important is we need to make the simple and easy and small size. The antenna, we called it terminal, all-in-one solution. Okay, so if you make the terminal more smart, okay, and simple and easy and more lower power consumption and lighter, and then that will be widely used by the the different levels customer, like the government, like the enterprises, like the consumer. Okay, and so you see the Starlink, we also the work more closely with vehicle the industries. Okay, so that is because you see the vehicle can be used in around the millions of. Okay, so that is create the more opportunities for the satellite communications adoption, right? They want to empower, since there are a lot of places there is no connectivity. So satellite and with 5G and also with multi frequency multiband, that is very necessary and to be widely used by the the different levels of the customers. That make the antenna very possible and very just versatile and to be widely accepted.
So that sounds like a mostly false. Thank you. Geoffroy?
Really? I'm going to be shorter. I think the Satcom terminals are enablers because they can enable a lot of new use cases. They can really bring services where we didn't think it could bring it. But again, price is the pain point and we need to lower it.
Okay, super. Thank you so much to both of our panelists. Can we give them please a warm round of applause? And thank you all so much. Have a great rest of conference.